10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff. Liftoff of NOAA's GOES-18, our newest weather sentinel in the sky to help keep us safe here on the ground.
Good evening, everybody. Welcome to the Carolina Weather Group. Another wonderful show coming to you tonight about GOES-18, the brand new GOES-R series weather satellite, the third in the series. We'll be talking to Dan Lindsey from NOAA, all about the satellite and all about how it's going, how it's getting into operations, and what we can expect from it as we get into next year. Joining us on the panel tonight is Shay Gibson and Frank Strait. So everybody, welcome on. And Dan, I know this is you're probably, I think this is your first time with us, if I recall. So one thing that we like to ask everybody before we get into the meat of the topic is, talk to us a little bit about how you got into weather. What's your weather journey like?
First of all, thank you for having me. It's an honor to be here. So my weather journey began, so first of all, I grew up in Georgia, North Georgia, about an hour north of Atlanta. And in the early 90s, some people probably remember a couple of noteworthy weather events that happened back-to-back years. The first one was in 1993, March of 93, the so-called storm of the century, which of course affected a very large part of the eastern seaboard, I guess, all the way from Georgia up to, far into the Northeast. And in my hometown, a little town called Jasper, we got 16 inches of snow, which, for there is highly unusual. Typically we'll get an inch or two, maybe once a year at most. But it was super exciting. I was in high school and, went outside and played in the snow and we didn't, the bad part, I guess, is we didn't have any power or water for a week because it's, lots of down power lines. And, as a teenager, that didn't bother me at all. But of course, it was a much bigger deal for a lot of people. So that was one thing. And then the second thing is the following year in 1994, this was not as fun. We had the Palm Sunday tornado outbreak. I believe it was in April, either March or April of 94. And that ended up killing a lot of people, including 9 in my home county, due to, and there were actually, I believe there were 2 tornadoes on the same day, one of which ended up being really rated an F3. So really it was those 2 events back-to-back years when I was in high school that got me really interested in weather. And, I started college in 95 and then sort of took it from there.
We all seem to have 1 or 2 of those events that get us going. I remember March 93 very much. That one scared me so much because it knocked the Weather Channel off the air. And I knew if the Weather Channel was knocked off the air, that was serious business.
Yeah, I think we got a few flakes here in Charleston, and that wind was just, it was blowing.
It was cranking. It was cranking. No, I remember that.
I was living in Columbia at the time. My hometown's Rock Hill. And that day we drove up to Rock Hill in the pouring rain to visit family, but then had to drive back in the snow in an 89 Ford Festiva. Did surprisingly well in the snow.
Dan, tell us a little bit about, maybe refresh everybody's memory on, the importance of GOES-R and how we got to this point and what we're working on now with the new satellite.
GOES, as many things in NOAA and in the government, is an acronym, and it stands for Geostationary Operational Environmental Satellites. And we've had GOES flying all the way from the mid-1970s. And so GOES-1 was launched in 1975 and just basically nonstop coverage of geostationary satellites in the Western Hemisphere since then. Every few years, they improve the technology. They'll upgrade the instruments, make the imager better, et cetera, sometimes add new instruments. And we sort of think of that as different generations of GOES. And back in 2016, it was the current generation was first launched. We call it the GOES-R series. And it's a little bit confusing because you go from letters to numbers, but the way it works is before the satellites are launched, you give them the letters. So, A, B, C, D, E, F, G, et cetera. And then after they're launched and they reach geostationary orbit successfully, they then are given a number. So you end up with satellites in orbit that have sequential numbers. So GOES-R was the first one, launched in 2016. It became GOES-16. And then a couple years later in 2018, we launched GOES-S, which became GOES-17. Those subsequently became the operational GOES-East and GOES-West satellites, which they still are today. And then the third in the series, as you just said, is the GOES-T satellite, was launched back on March 1st of this year from Cape Canaveral. Beautiful launch. Those are, if you can ever make it down there to catch one of those launches, it's definitely worth the trip. Everything is going great, and after it reached orbit, it became GOES-18. So that's where we are today, and we're in the middle of the checkout phase, which I can say more about if you'd like.
Yeah, absolutely. Let's talk about that. I know, and we got some initial images from it last week too, and it's already drifting into where it's going to be, right?
That's correct. So typically, the checkout phase is done by putting the satellite in the center of the country. We call it the checkout location. The longitude, they're all over the equator. That's one necessary thing for geostationary satellites, to be able to view the same place at all times. But the longitude is what changes. And so this one is centered at 89.5 west longitude during the checkout. That's where all of the 3 satellites were checked out. And this time we did it a little bit differently. We did launch it to 89.5, and it did several weeks of checkout there. And then, and now, as of, I guess, last week, I can't remember the exact day, we turned the instruments off, or at least stop scanning with the instruments, and we begin moving the satellite out to the west position. So right now, as we speak, it's somewhere between the center of the country and the western location, which is at 137 degrees west. The plan is for it to arrive there in around June 6th, I believe, something like that. And then after it arrives, we will proceed with the post-launch testing. So it's sort of split up the testing into 2 pieces, from 89.5, and then we'll do the rest of it from that western position near 137 west. That will continue through the rest of the year. And then, you know, you can do lots of comparisons between GOES-17 and GOES-18, since they'll be virtually side by side in orbit. And that'll help, you know, with the calibration and everything. And then in early 2023, is when GOES-18 will become the operational GOES-West. It'll take over for GOES-17 at that time.
So Dan, what happens to GOES-17 when GOES-18 becomes the operational satellite?
So GOES-17, after that switchover is done in January of 2023, will then be moved back to close to the center of the country. It's a slightly different longitude. It'll be at 105 west, which, if you look at a map, is over roughly Colorado, that longitude. And there it will become the on-orbit spare. So right now, you know, we have GOES-14 serving as a backup, sort of an emergency backup. It's at that longitude of 105. But once GOES-17 reaches that, it will become the on-orbit spare. And what that means is, if there's ever a problem with either GOES-East or GOES-West, anything that happens, it stops scanning, you know, those kind of things, then we will turn on GOES-17 again, and it will serve as the backup for those other 2.
We'll have GOES-17 sitting up there and essentially sleeping. Is there a reason why we're not using it to get extra data? Does it cause like wear and tear on the satellite if you're using it? So we're saving it. Is that the reason why?
Yeah, there's a couple reasons. Wear and tear is one of them. You know, the more you operate the satellite and the more you do things with it, I'll use that term loosely, it does wear down with time. I mean, these satellites have, you know, something like a 10-year life expectancy, and the fuel, you know, to keep it in a certain longitude position, you sometimes have to move it around, and that uses fuel, things like that. That's a limiting factor. And then the other reason is, yeah, that's really the main reason, I guess. Oh, I know what I was going to say. Apologies. The other reason is it's difficult to have all 3 satellites being operated from the ground at the same time, because we have a part of NOAA NESDIS where I work is in Suitland, Maryland, and we call it OSPO. It's the operations arm of NESDIS, and they have people staffed 24/7 to operate these satellites. And, you know, if anything goes wrong in the middle of the night, so really what they have staffed to do is 2 satellites. And so to have 3 would really be, you know, difficult for them. And there's just not really the manpower, is the best way to put it, to do all 3.
It's a question for me, and for our listeners out there, kind of explain the entire program. You're sort of the science authority for this entire mission with GOES-18. And so tell us a little bit about all the things that this satellite's going to be doing for us in the new age of satellites.
The GOES-R series has a bunch of different instruments. So the one that gets the most attention, I guess, the most press, is the one that makes these images that you saw first last week. It's called the Advanced Baseline Imager. It's sort of our longest running instrument. I mentioned GOES-1, launched back in 1975. It had an imager of sorts where it's basically collecting visible and infrared data. And those imagers get better and better with time. So that's sort of the baseline, the primary instrument is what we like to call it. But there's actually quite a few more instruments that the GOES-R series carries, and I can talk about them a little bit here. So one of them is called the Geostationary Lightning Mapper. You'll hear GLM for that acronym. This is the first time, starting with GOES-16, the first time we've had the ability to detect lightning from geostationary orbit. And the advantage of that is, from being geo, is you're not going to miss the lightning. You're staring at the same place since it's in geo, and you're just watching the flashes on the top of the clouds. It's an optical instrument, so it is literally looking for the clouds becoming slightly brighter for a brief amount of time associated with the lightning during the daytime, and then of course at night it's much more bright since you don't have the sun reflecting also. So that's one big upgrade that we had with GOES-16, was adding the lightning mapper. The rest of the instruments that it carries are, we call them our space weather suite. So they're actually more interested in it in looking at the sun. One of them is called SUVI. It's a solar ultraviolet imager, and it literally takes pictures of the sun in the ultraviolet. So whenever you have sunspots or these solar storms that happen, SUVI is able to get pictures of those. And that's the type of thing that we need to know about, because it'll send things like coronal mass ejections to the Earth. And sometimes we have to do things like, people on the space station, these things can be dangerous. And so get the astronauts in a safe place, and even satellites themselves can be affected. So, put the satellites in safe mode, that kind of thing. And then the other instruments are, all of the other instruments are sort of related to these solar particles or dangerous solar radiation. I'll just give the names. They're called EXIS. One is called SICE. It's a space, that one is the one that measures the actual harmful particles themselves. And then there's something called the magnetometer, and that measures the magnetic field around the Earth. So I think I got them all. I know that's quite a few instruments on top of just the ABI, sort of our standard imager.
I think the first question too, that going back to GOES-18 and its eventual mission, you mentioned that it was going to be the operational GOES-West satellite. Mm-hmm. Now, GOES-17 currently is the operational GOES-West satellite. Seems kind of quick to replace. Mm-hmm. Explain to our viewers what's happening and why we're doing that.
Yeah, so you may remember shortly after NOAA launched GOES-17 back in 2018, when during the checkout phase, they quickly realized that there was an issue with the cooling system on the Advanced Baseline Imager related to a component of the cooling system known as the loop heat pipes. Basically, they take heat that the sun shines on the satellite, really heats it up. And so the idea is you collect the heat and then you move it with the loop heat pipes over to the radiator, and it radiates out to space. So the loop heat pipes weren't working exactly the way they were designed. And so the result of that is, during certain times of day and year, the detectors themselves get hotter than they're designed to get. And when they get too hot, we sort of lose the imagery. So the good part, though, is it only happens with some of the infrared bands. Like the visible channels aren't affected at all. It's only beyond, say, 6 micrometers that you have an effect. The other good part is it only happens in the middle of the night for a few hours, and also there's certain times of year that it's worse. But we're not getting all 16 channels 24 hours a day, 365 days a year. We do have these outages. It still ends up being more than 90% of the data that it was designed, but it's enough of an outage that we're launching a new satellite. It's in great working order. We might as well move it over and put it into West service so we don't have these outages. So that's the plan. Is GOES-17 is still operating. It's still working just fine, except for those outages that we have at night with some of the infrared channels. And that's the reason that we're going to go ahead and put 18 in service immediately.
I understand from the from the transition website. There's a whole website on goesr.gov, talks about for our viewers to go to check out, and you can read exactly all of the nerdy details of how we're going to put this thing into service here. But one cool thing that I noticed is that when it gets into that west position, we turn it on, and we get to that point where that loop heat pipe anomaly becomes a problem. It sounds like y'all have a way to actually use 18, relay it through 17 to supplement that data.
Correct. Yeah, I'm glad you brought that up. This is something we're excited about. We call it interleaving. And the idea is, so I mentioned how the GOES-17 loop heat pipe anomaly is worse certain times of year. It turns out that those worst times are before and after the equinoxes. So so the next bad time will be the month of August, which is before the autumn equinox, and then again from about mid-October through mid-November, and that's after the equinox ends. So those are sort of the worst times of the year of this upcoming period. And so it's during those 2-month periods that, yes, we will be collecting ABI data from GOES-18 and sending it through the channels of GOES-17. And so all of the official sort of operational data flows during that 2-month period. If you go to GOES West, you will actually be getting GOES-18 data during that time, even though it's not the official operational GOES West yet. So it's sort of, you can think of it as pinch hitting for that 2-month period when we really have the most degraded data from GOES-17.
Will we have to put a bunch of preliminary and non-operational disclaimers on those?
Well, yeah, I mean, technically it is preliminary, it is non-operational. And so, at some point we can stop doing that. I think it's whenever we reach something called the provisional validation stage. And I'd have to go back and double check the planned date for that. That provisional validation stage may occur before August. And if that's the case, then that sort of removes the reasoning for putting down the non-operational disclaimer.
I mean, that's a good point, Jared. I was going to ask, from a viewer standpoint, we know something's in orbit up there, right? So what's the deal? How long does it take to get the data flowing where it's actually official information versus, because I think a lot of folks think once it goes up, it's going to be operational the next day. So explain, kind of tell us how that works.
So there's lots of things that have to be checked out, not just the instrument itself, but the satellite itself. You have to make sure that it has, that it's pointing correctly, in order to get the data where, say, for example, let's say you take an image of South Florida, which has a very distinct coastline, and you assign a latitude, longitude to that point in South Florida. You have to make sure that the latitude and longitude that you think you're looking at really is that latitude, longitude. So we call that the navigation. We have to make sure the satellite is pointed correctly and that we're collecting the data in the location that we think it is. The other thing is the calibration itself. So the satellite is measuring these radiances or radiation from the Earth that we put into the unit of radiances. And we have to make sure that those radiances are exactly calibrated correctly. And what that means is, if the satellite is telling us that this is an 80% reflectant cloud, then it really needs to be 80% and not 70 or 90. And the reason is, if it's off, then that can mess up the algorithms that are actually relying on the quantitative data itself. So it's this type of careful calibration validation that has to be done during this multi-month period. There's a whole string of tests. Many of them are engineering related, which honestly I don't completely understand, not being an engineer. But it's important things that with any satellite launch that they have to go through to make sure everything is just exactly perfect.
The average weather enthusiast knows that GOES satellite data is used by the Weather Service in their forecasting, that they see it on television with their TV meteorologists. They see these beautiful pictures on social media of all the various data types. What are other ways that the satellite data in general is used?
One of my favorite applications of the data that honestly we didn't understand at the beginning how good it would be until we actually started getting the data is for fire detection. So, the primary goal is looking at clouds and weather, but it turns out it's really, really good at detecting fires. And the reason is because the fires themselves, they cause a thermal anomaly. And what that means is it gets really hot, of course, associated with a fire compared to the surrounding area. And so one of our channels in particular, it's the 3.9 micrometer channel, band 7, is very sensitive to subpixel fires. And the resolution of that channel is 2 kilometers at nadir. Nadir means directly below the satellite. So when you're looking at, say, California, it's a little bit bigger than that, but roughly 2 by 2 kilometers. But the beauty of it is you don't need a fire to be 2 by 2 kilometers in size to see it or to detect it. It can be notably smaller than that. It can be, say, on the order of, say, here's an example actually that one of our Weather Service colleagues noticed. So this was a few years ago in Kentucky, I think. They were looking at this Weather Service forecaster was looking at the ABI data, band 7, and noticed what looked like a fire. And he called it in, and said, local emergency manager or sheriff or whoever, go out. Here's the latitude, longitude. Is this a fire? Go out and check. And so they did. It turns out it was a barn that was burning, that was in a remote area. I guess there were in the middle of the night. It's hard for people to notice. And so that's just an example. Of course, the main mission is not to detect barn fires, but that's just to give you an idea of if you have a small enough something that's burning really hot, we can detect it. And so this is important, especially out west. As you all know, we've had many, many wildfires over the last few years, especially California, Oregon, and the surrounding states. And we really need to keep a close watch on those fires. And GOES-West is in a great position to do that. With the low latency of the data, meaning we take the image and get the information down to the earth within just a couple minutes. That really makes it good for detecting the fires, noticing the anomaly, and then alerting someone, because sometimes if it's early enough, they might even be able to get out and put the fire out before it gets out of control. So that's one example of a way that the data is used beyond just sort of the typical weather applications.
One last question before we go to Frank, and some fun questions. A lot of people will see pictures of the 16 channels of ABI data, and they'll notice that there's a ton that are black and white. And I have seen questions, and it's like, we paid all this money for this satellite. Why is everything in black and white? But there are ways to synthesize that.
Mm-hmm.
Tell me a little bit about some of those algorithms and how we get color images out of this. If we, the introductory video is a beautiful true color image.
Yeah, great question. This is one of my favorite topics, actually, and something that, we were first able to do really well with GOES-16. So typically, I should say, previous to the GOES-R series, our imagers had only one channel in the visible portion of the spectrum. And so, you can think of it as monochromatic. It's just giving you one color, if you think about it that way. And so we don't have an indication of how, whether something is more green or red or blue or yellow or brown or whatever. We just basically have, is it reflective in the visible portion of the spectrum? And so that's why NOAA typically, or pretty much anybody will, if they just have the single visible channel, they'll make it black and white because it makes a cloud look like a cloud. And these clouds, it turns out, actually are white. And we don't have any more information with the old imagers, is the bottom line. And even today, it GOES-16, its highest resolution channel is the channel 2, which is it's the only one that's the 500-meter resolution. So a lot of times you will still see black and white. And the reason is because that single channel has the highest resolution. And if you go to something else, you're going to be degrading the resolution a little bit. Now, the ABI brought is additional bands in the visible. There's a band in the blue portion of the spectrum, about 0.47 micrometers. And there's one in the near infrared portion at 0.86, which is actually a little bit beyond what our eyes can see, but we can still use that information to get at the greenness. So if you combine the red, the blue, and really some other information, I don't want to get into the gory details, you can come up with what's essentially an approximation of the true color. And so the first images that you saw is an example of that. This is an algorithm which was developed actually here where I sit at CIRA, the Cooperative Institute for Research in the Atmosphere at Colorado State University. And it's really, it provides a beautiful image, number one, but it also has value for forecasters because it's really easy to find smoke and blowing dust in these aerosols. And it's even easy for the public to do that. You put these images on social media or put them on TV news, et cetera. And anyone can look and say, oh, that looks like smoke from a fire. And that's exactly what it is, because the color matches sort of what the actual color is.
We'll start out with some questions about what you like doing in Colorado and what life is like out there. So tell us, somebody who's visiting Colorado, and specifically Fort Collins, what do you enjoy doing? What's something you got to do if you're visiting that area?
This goes back to my schooling, actually. Is I got my undergrad degree at University of Georgia in the state that I grew up, and then I was trying to decide where to go to graduate school. And I applied at several different places, and one of the places I got into was Colorado State. And I learned to ski in the mountains of North Carolina since I grew up in North Georgia. And some of you've probably skied in the mountains, and there's some great mountains there for sure. But then when I was in high school, I went on vacation and went skiing in Colorado, and it's just a completely different scale. Big mountains and multiple ski lifts and everything. And I fell in love with skiing at that point. And I got to say, it was actually more the skiing that drew me to CSU to grad school than it was the program itself. Of course, it is a really great graduate program too. So I will say I'm a huge snow fan, even though I grew up in Georgia, and maybe it is that March '93 blizzard which really made me love snow. But if it could be January here all year long, I would be happy. And not many people agree with that sentiment, but that's my opinion. Love snow. I don't like the heat. So I do like to do things in the outdoors. Skiing is probably at the top of the list, and a little bit of hiking and things like that too.
What's unique about Colorado's cuisine, and what's the best place to get it?
Colorado cuisine is probably most influenced by the Southwest. So you think of Tex-Mex, places like New Mexico, they're famous for things like green chili. That definitely has seeped into Colorado as well. And so there's a lot of really good Tex-Mex, New Mexican, whatever you want to call it, that type of fare out here, which I really like. And really in Fort Collins, you can find restaurants that cover pretty much everything. You think about any sort of food type, there's some really good Asian places. That's the case pretty much anywhere probably. But even seafood, you can't get much further from the ocean than here in the U.S. But there are actually some really good seafood places as well. But I would say, I don't know, you may get a different answer depending on who you ask from Colorado. But I would go with some variation of Mexican or New Mexican as being my favorite type.
Aside from the skiing, what other kinds of outdoor type activities can you enjoy in Colorado? It seems like it could be an outdoorsman's paradise.
Really, hiking in general. I know rock climbing is really big. That's not something I have ever actually tried. Mountain biking. These are all, relatively warm season activities, generally speaking, since it does get a little chilly here in the middle of winter. Those are probably the top few. There's a lot of people are runners. People that are really hardcore runners will come to Colorado to train because of the elevation. You train at elevation and then you go back and you run a marathon at sea level. It gives you a big advantage. I'm none of those things. So I'm just sort of reporting what I see other people do around here. Outdoors is a big thing here in Colorado.
So I think the last question that we always like to ask is how can we follow along GOES-18's journey and keep up with what Nestis is up to using social media or other websites or anything like that?
Sure, yeah. So probably the best way is the NOAA Satellites Twitter feed. They're not only on Twitter, I believe they're also on Facebook and probably Instagram and maybe others. Twitter is the one I'm most familiar with, which is the reason I mentioned that. Anytime there's a big thing like the release of the ABI first imagery last week, that's something that you'll see first on the Twitter feed. Once GOES-18 does reach its checkout locate or get to the west location here in a few weeks, you probably will begin to see some of that imagery on some of the websites that you typically go to. You can just look around for those, and it will have probably that non-operational disclaimer for a while. But anyway, that'll be a great place though to go and check it out yourself if you want to do some comparisons between, say, GOES-17 and GOES-18.
No, that's fantastic. Well, Dan, it was wonderful to get to talk to you about this brand new satellite. We are all huge fans of the GOES-R series. We do not know what life was like before them, and we never want to go back to life before them. That is for sure. So, Dan, on behalf of the panel, Shay Gibson and Frank Strait, thank you so much. I'm Jared Smith, and thank you for watching or listening or however you got the Carolina Weather Group tonight. We're glad you joined us, and we hope you'll be back